8.2, operations with matrices. We're going to add, subtract, multiply matrices. We don't divide. We don't. I don't know. Matrices we've talked about, we've worked with, we can name them with a capital, we can name them with a lowercase, and then the IJ is the number of rows, the number of columns, because it's row columns all the time. So like if I want this term, it's A sub 3, 2, that means it's in the third row, second column. Okay, those are just some things. Okay, two matrices that are equal, that means their corresponding entries are equal. These are entries, elements, terms, all different things. So what does 2x plus 1 equal? And I touched it. What does 2x plus 1 equal?
5.
5. So how could we solve for x? Set them equal to each other, and is 4, and x is 2. I also could have put 3x equal to 6 and gotten what? 2. Make sense?
Mm-hmm.
So what does y equal?
4.
4
3y.
equals 3y minus 5. So 9, so 3.
Yeah.
So corresponding terms are equal. Got it?
Mm-hmm.
Okay. Which kind of makes sense, right? Matrices, when you add or subtract, you just combine corresponding terms. That's it. So A plus B. Why do I always touch it before? It should just turn on. So A plus B is 2 plus 0, so it is 2. And then what? 2. What's my problem?
Yep.
Does it work? Nope. Hence, my statement up here that I didn't read to you, they have to have the same size or order. So this is undefined. Can I do this one?
Yeah.
Yeah. So I'd get what? 0.
Negative 1 and 3.
Okay, got it? Alex, wake up. Okay, operations with matrices, numbers outside the matrices, they're called scalars. Scalar multiplication, each element is multiplied by the scalar. You're just distributing it in.
Mm-hmm.
So negative 3 is my scalar, and so I get 3, negative 18, negative 33, and negative 12.
Mm-hmm.
The symbol negative A represents the negation of A, means everything is multiplied by negative 1. Just like if I put a negative outside of parentheses, I multiply everything by negative 1, correct? All operations are similar. The only thing you can't do with matrices that we do with everything else is divide. You can distribute, you can multiply as long as it meets the restrictions of multiplication. Okay, so what's A tell me to do? So what does that mean?
Times it by 3.
Multiply everything in A by 3. So what do I get?
6, 12, -9, 0, -3, +6, 3, +.
Okay. What does B tell me to do? Take the negative of it. So everything becomes negative or positive. Everything switches a sign, right? What does C tell me to do?
Minus, well, combine.
What, Emma?
Combine.
Combine what? Yeah, it says combine A and B. I have to take 3 times A, right? And then if I distribute my negative into B, then I just combine them. So you guys do that. Wow, I turn on your alarm since I haven't had it on forever. Did you get the same thing I did?
No.
Why not?
No, because you didn't take 3A. You just did A.
Oh, I just did A. I didn't look down, did I? Let me try that again. So 4, negative
Wait,
10.
you don't distribute the
7.
negative?
I already did right here. Just because this is negative B.
Oh,
So 6, 4, 0, 12, negative 6, 4. Now do we have the same thing?
yeah.
Okay. Do I have to multiply by 3 before I subtract? Yes, because my order of operations. Correct?
Yes.
Okay. Alex, you good?
Yeah.
Okay. So these are just addition to say commutative property works. AB is the same as BA. Associative property works. So if I have A plus B plus C, doing B plus C first is the same as A plus B first plus C. The associative, nothing moved. I can take CD times A, or I can take D times A times C. I could also take C times A times D. Now, C and D are scalars there. I want to be very clear. Those are scalars. Those are not matrices because they're lowercase. Okay? Matrix multiplication by principle is not commutative. Okay, we have certain circumstances where it is. Okay, scalar identity property is the next one. What is the one thing I can multiply everything by and get the same thing? 1. So if I multiply in the matrix by 1, you get the same matrix. Distributive property. So C times the quantity A plus B is the same as CA plus CB. I can also take 2 scalars plus each other, and then so I can distribute a matrix over scalars or a scalar over matrices. That's what this is. We also have left and right hand products, and we'll look at those tomorrow, I think. Okay, if A is M by N, 0 is 0 matrix. Guess what it's full of? Zeros. So if I add it to it, I'm going to get the same thing. That's called the additive identity. So the multiplicative identity is 1, right? The additive identity is 0. Well, the scalar multiplicative identity, not scalar multiplication. I said that wrong. So if you didn't want to change it, you'd add all zeros, which I don't think you do much. And I'm pretty sure this is tomorrow's. Because I'm pretty sure you just add, subtract, and do scalar multiplication today. Now you got all the time in the world.